Okay, so now we're going to be looking at group 7 elements, and so this is group 7 here. It starts with fluorine, then chlorine, bromine, iodine, and finally astatine. Okay, we're going to be looking at its properties, how it looks, and how they can react with other things. Okay, so what I've done is I've already made a table with the halogen, what the formula is, what the color is, and what state it's at room temperature. So if we start off right at the top of group 7, it's fluorine. Okay, so here's fluorine. Now this has a formula of F2. Now I want you to really look at the names, okay, because this becomes important quite later on. When they are in their natural state, diatomic, i.e. they're not bonded with anything except themselves, because there's two F's here, it ends in INE, so this is called fluorine. Now fluorine has a color which is pale yellow. Okay, so fluorine is a pale yellow color, and at room temperature it is a gas. Okay, so that's fluorine done. Next we're gonna have a look at chlorine. Okay, so chlorine, again, notice it ends in INE when it's on its own, and notice that it's Cl2 because it exists as diatomic state. There's only two molecules that make up chlorine. It's joined to itself twice. And chlorine is a yellow green color. Okay, so it's a yellow green color, and this is also a gas at room temperature. So let's underline this and let's go on to the next one. The next one is bromine, right? Again, notice on its own it's INE, it ends in INE, and bromine is diatomic as well, so the formula for it while it's on its own is Br2, and bromine is like an orangey brown color. So it's an orangey color. Okay, so orange brown color, right? And at room temperature this is a liquid. Okay, so this is a liquid at room temperature. Next we've got iodine. So we've got iodine next. Now iodine, again, it's diatomic, so again notice it ends in INE and it is I2. Its formula is I2. Now its color is a silver color, and it is a solid at room temperature. So it's kind of like a silvery solid material, and that's it. So notice that it's gas, liquid, solid. So as you're going down the group, it's boiling point. So boiling point, remember, is when something goes from a liquid to a gas. So its boiling point is increasing as we go down the group. So its boiling point is increasing. Now its reactivity, however, right, its reactivity as it's going down the group decreases. Okay, so the fluorine is the most reactive, iodine is the least reactive. Right, okay, and so these are the physical characteristics of group 7 halogen. Now group 7 elements are also called halogens. Okay, so let's get rid of all of this. Now I want you guys to notice that this is the opposite trend of group 1. Group 1, as you went down the group, the reactivity increased, whereas with group 7, as you go down the group, the reactivity decreases. Okay, so don't get confused between the two. Make it very clear to yourself that this is increasing and the other one is decreasing. Now what we could do is we can react the halogens with metals, okay, and that'll be ionic bonding, because when we react a metal with a non-metal, this is an example of ionic bonding, as we've already covered. However, let's actually react some together. So if I just look at my periodic table and I look at potassium, where is potassium? It's in group 1. Okay, so we're going to react potassium with a halide. Let's react it with chlorine. Okay, so what I'm going to have potassium, it's my word equation, plus chlorine. Now notice it's INE, and when we react these together, we're going to have a new compound called potassium chloride, right? Potassium chloride. And so the formula for this would be K plus Cl2 makes KCl, right? And look at this, we've got 2 chlorines here but only 1 here, so I'm going to put a big 2 in front of that. And so I've got 2 chlorines, but I got 2 potassium here and only 1 here, so I'm going to balance that, and everything is now balanced. Now what I want you guys to notice is this bit here. Can you see how the chlorine has turned to chloride? Very, very important, okay, that you notice that. Now let's make another one. Let's say it's going to be calcium. Now guys, how do I know that this is the formula? Again, we need to go back to our ionic equation. Okay, this is in group 1, so this is going to be K plus, because it's going to lose 1 electron, plus Cl minus, this needs 1 electron. If you cross these over, cross over the numbers, there's going to be 1 K and 1 Cl. Now let's try it with a group 2 metal. Okay, so with a group 2 metal, what we're going to have is we're going to have calcium, which is a group 2 metal. How do I know that? It's from the periodic table. Let me just show you. Oops. So here's calcium, right? It's a group 2 metal. Look, there's beryllium, magnesium, calcium. It's a group 2 metal. So if I go back and just get rid of this, so calcium is a group 2 metal, as we just saw, and we're going to react it with, let's say, bromine. Okay, and what this is going to make, notice it starts with INE, but when it reacts and combines with something, it becomes IDE. This is going to become calcium bromide, IDE. So if we look at this, calcium is in group 2, so it's going to lose 2 electrons, right? Bromine is in group 7, so it needs 1 more electron. So if it gains 1 electron, it's going to become negative. You cross them over. How many calciums do you have? Well, that represents 1, so I'm going to have 1. How many bromines are you going to have? That's going to be 2, right? And so what we can say now is calcium plus bromine is going to make calcium bromide, Br2. So hopefully you can see how to work out what the formula is. Now for foundation, right, they'll probably give it to you and you'll just have to kind of arrange it in some type of equation. But however, it's really good if you do know how to work that out. If you don't, probably don't worry about it too much. They'll probably give it to you in the question and you just have to figure it out. Now what I want to note for you guys is this bit here, right, is a salt. These are called salts. In particular, these are called halides. Okay, these are called metal halides because it's got a metal bit and it's got something belonging to the halogen and it ends in IDE. So it's called, these are called metal halides, right? And I hope that that makes sense. So we can make our metal halides from these. Next, what we're going to do is we're going to react our metal halides in a displacement reaction. Now, displacement reaction is a type of reaction where I'll explain it by using the periodic table. So that's what we're looking at now, displacement reaction. So let's go back to our periodic table and let me show you. Let me just decrease the opacity. So let me show you this. You see this fluorine here? This is the strongest of the most reactive of the group 7 iodine is the least reactive. Now you need to remember that in order to understand this. Now the way I teach this is to think of this as being the bully. Right, now the biggest bully here, this guy can bully anybody. Right, and he can take anything off anybody. And this guy is like the weakling, if you like. This guy can't touch anybody, he can't take anything off anybody. Okay, he's the weakling, and this guy is the bully. So that's how to remember it. Now it's gonna make sense once I go through it. Okay, so I remember fluorine, that's INE, is the biggest bully. Fluorine. Iodine, that's INE, is the weakling. It cannot bully anybody, it cannot take anything off anybody. So what does this mean in reality? Okay, so this is displacement reactions. So let's say we've got KBr, so that is potassium bromide. Potassium bromide. Right, and let's say we're going to react it with chlorine. Right, so remember chlorine is Cl2, so we're going to react it with chlorine. Right, the question is, are we going to have a reaction? And to do this we need to look back at our periodic table. So remember what we said is that it's potassium bromide is going to react with chlorine. Now chlorine is a bigger bully. Chlorine, INE, is a bigger bully. So yes, it's going to bully potassium bromide and leave and take whatever the bromide has and leave it on its own. So here's my potassium bromide, here's my chlorine. The chlorine is going to bully the bromine, so the bromine is going to be left on its own. So the bromine is going to be left on its own, and the chlorine is going to steal the potassium, because that's what bullies do. That's KCl. So you got your potassium chloride plus your bromine, and so this is going to form, so if we look at the word equation, it's potassium bromide plus chlorine makes potassium chloride plus your bromine, INE, because remember this is now diatomic, it's alone, it's called bromine now. Let's do another example. Let's take potassium iodide. So let me just change colors as well. Why not? Why not? So let's just take potassium iodide. So it's potassium iodide plus let's do it with bromine, and we're going to see if there's a reaction. Now to figure it out, let's go back to our periodic table. So remember it's potassium iodide with bromine. Now can you see that bromine can bully iodine because bromine's above, so bromine is going to steal whatever iodine has. So yes, is there going to be a reaction? Yes, because bromine can bully iodine. So potassium iodide plus bromine is going to make potassium bromide. Now notice the bromine turns to iod because it's now with somebody, plus your iodine. So how does that look in the equation? Well, you're going to have Ki for potassium iodide plus Br2. It's going to make potassium, so that's K, Br for bromide, plus your iodine. Right, and now what we're going to look here is it balanced? Now I've got two iodines here, but only one on this side, so I'm going to put a 2 in front of there. Right, so now I've got two iodines, 2 potassiums on this side. However, I've only got one potassium on this side and one bromine, so I'm going to put my 2 there. Now I've got 2 potassiums here and 2 bromines here, so this is 2 bromines, and I've got 2 bromines here, so it's balanced. Same with the one above. So if I go back to the pink one, I'm just going to change it to red. So if we go to KBr, we've got 2 Cls here, but we've only got 1 Cl2 here, and we've got 2 Br2 here. Well, we've got Br2 here and only 1 Br here. I'm going to put a 2 in front of that, so that gives me the Brs are now balanced. Can you see I've got 2 of those and I've got 2 of those. My potassium is not balanced though, because I've got 2 of these but only 1 of these, so I'm going to put a 2 there. So now I've got 2 potassiums, and I've got 2 chlorines here, and I've got 2 chlorines here, so it's all balanced. So now let's look at one other one, just to illustrate some examples. Okay, so you guys should be able to look at the periodic table and figure out whether there's going to be a reaction or not, and it's based on which one is more reactive I replaced the word reactive with the word bully, but it's the same thing. In your exam, you're going to be talking about which one is more reactive. However, you need to think about it in the sense of which one's the bigger bully. Right, so let's look at this one. Let's say we've got potassium fluoride. And guys, notice because it's with potassium, because it's with a metal, it changed to IDE plus chlorine. Okay, so plus chlorine, and we're going to see if there's a reaction. Okay, let's have a look. So let's have a look at our thing. So what we're asking is, can chlorine bully and take something off the fluorine? And the answer is no, because this cannot bully. It cannot bully the fluorine. Or another way of saying it, the scientific way, is it's not as reactive as fluorine. So chlorine is not as reactive as fluorine, therefore it's not going to touch anything or take anything from it. So here we're going to have no reaction. Why? Because chlorine cannot bully the fluoride, because the fluoride is more reactive. So let's look at another one. So let's go for potassium chloride plus fluorine. Now again, guys, notice the IDE because it's with potassium. Notice the INE because it's on its own. So can fluorine bully chloride? And the answer is yes, because the fluorine is higher up. It's a bigger bully, it's more reactive. So are we going to see a reaction? Yes, indeed we are. And so the reaction is going to be here. Potassium fluoride, potassium fluoride plus your chlorine, which is going to be on its own because it's just been bullied. So the equation for that is KCl plus F2 makes KF plus Cl2. Just balance it. You got a 2 here and a 2 here, and it's balanced. Alright, so that is halogens and its reaction. Those are displacement reactions. That's how to figure out whether something can react or can't react, and that'll do me there.